right. If you've clicked on this one, it's because you've realized we have not actually gone over the engineering design process in class. It's very similar to the scientific method, so you'll do fine after listening to this. The main differences between engineering design process and the scientific method is the purpose and the goal. For engineering, the purpose is to create a solution to a specific problem. So, for example, you might look to a sanitation engineer if you have, if you're looking at the problem of how to take care of the city's sewage. So, a civic engineer would take a look at that and create a solution to the problem of the city's wastewater. In science, the purpose is generally just to discover things, generally about the natural world. So it could be physics and how things move and how gravity affects things. It could be biology, from why do the animals hibernate and what happens with their metabolic rates during hibernation. It's just sort of to discover things. The goal of engineering is to create a cost-effective, workable solution. So again, you're going back to that, creating an actual answer, a solution to a problem that currently exists. Not only that, cost is a big thing to consider during engineering, because you could create the best solution to a problem, but if it's so expensive that no one can afford it, then it's not going to do anyone much good. So part of the engineering is wrapped up in the cost of actually implementing your solution. Whereas in science, our goal is really just to add to the collective knowledge and our understanding of the world and how things work and what can we do with it on an idealistic level. Engineering and science go hand in hand, because without discovering things about our natural world, without knowing how things work, it makes it much more difficult to create an actual solution to a problem. So these two things go hand in hand, even though they are a little bit different. Here's the design process. And it's kind of similar to the scientific method, but if you look at the top, number 1 is identify the problem, identify the criteria and constraints. And what we mean by this is, do you have a budget? Where is this actually going to be located? Are you going to be building this bridge in Antarctica, where temperature is going to be a huge factor? Or are you going to be building it in the rainforest, where moisture and humidity are going to be a huge factor? So identifying what you have to work with is number 2, which is very important and something that the scientific process doesn't always address very well, because we control our conditions, right? Number 3, brainstorm possible solutions. That should be pretty self-explanatory. Generate some ideas that actually work from those brainstorm sessions. Explore the possibilities. This is kind of the research step. So start researching some of those ideas. Has someone done it before? Can you use what they have done? Can you learn from their experience? And then to actually select one of those ideas that you think will be the best. And then build your model or prototype. And when you build your model or your prototype, you'll test it out, of course. And in the testing, you'll find ways to refine your design. So if your bridge doesn't hold up well to the humidity, then you've identified a problem. And so focusing on just the humidity problem, you'll then go back to the design process and keep refining your solution until you have one that works and that is cost effective. So identifying the problem, it's like conducting detective work. Examine the evidence and form some conclusions. An example, design an athletic shoe that decreases the amount of sprained ankles when worn on hardwood gym floors. So that would be your problem. Number 2 is identify criteria and constraints. Again, this is identifying what you must work with, including budget, materials, and the conditions in which you must perform. 3, 4, and 5 are kind of self-explanatory. Brainstorm possible solutions, generate a list of workable ideas from that brainstorm, and then do some research on them. After that, you'll select an approach. And here's where things are very different from the scientific method. You may have several workable good ideas. You're going to have to pick one or two possibly to move forward with. You can always come back and pick the other one or different ones if they don't work out. But once you select one, you'll build a model or prototype. In the case of like a bridge or a building, you might build a model. But in the case of something smaller like a car, or if you're trying to build a windmill to generate electricity using wind, you may actually choose to build a prototype, an actual full functioning prototype. So after you build this model or prototype, you'll test it out. You'll refine the design. You'll put it in place and see what works and see what doesn't work. And then after that, you may decide that it doesn't work and you need to go back and pick a different one. Or you may just identify the problem, going back to number one, with that specific model or design. So that's pretty much it. That's the engineering design process. It's not all that complicated or hard, and those of you that are in engineering, you'll do great with this. One thing to keep in mind, though, is the actual cost. A lot of times on the EOC, they're going to ask about the benefits of spending so much money to solve a problem that may not be important. So keep that in mind. Sometimes in the engineering design process, you have to weigh the cost versus the benefit. So is this solution going to, improve people's everyday lives? Is it going to provide some sort of service? And if so, is that service worth the money that it's going to cost you to implement it? So that's one thing to consider that we don't think about with the scientific method. If you have any questions, come see me, or you could stop by Mr. Guthrie or Miss Hamby and ask, but let me know.